Today we are going to go through the final operations inside a linked list, meaning we're going to pop, we are going to remove the last, and we are going to remove after a certain node or remove at a certain index. So popping means that we are going to remove the head, removing the last means that we are going to remove the tail of our linked list, and removing after certain node means that this is our certain node. We're going to remove this one, or if we want to remove a certain index, then let's say we want to remove at index 1, we are going to remove this node right over here. So let's just scroll all the way down after the insert function, and let's create our pop. So that will return the value that we are actually popping, not the node, but the value. We don't care about the node. It's irrelevant. So we might get because it's optional a value, because if we have an empty list, then it's nil. So at discardable result, public mutating func, and then just pop. We don't need anything else. It's just going to pop, and we might get back a value. So question mark for the optional part. So first of all, we want to make sure that we actually do have a head, so we can pop. So guard let current head equals our head, else we're just going to return nil, because the linked list is actually nil. And then we can just say return our current head dot value. Now, why do we do this right over here, even before we popped anything? At this stage, on the current head, we do know our value over there. But if we remove it, we no longer have access to it. So what we're going to do is use the defer. So defer, which is basically going to be triggered right before we return our value right over here. So we're going to say the new head equals our current head dot next. So the next one, that's why we are popping the first one, the head. And then we're just going to say count minus equals 1. Now, one thing to note over here, we also want to clean up. So we are going to return nil right over here if we don't have any elements, like we don't have the head. But we also need to make sure that we are setting the tail to nil too. You want to make sure that the tail is nil if we don't have a valid head. Okay, so that's how we pop. Next up is to remove the last. Removing the last is the last element. We need to traverse the whole linked list, which will be of O of n time complexity, not just I. We're going to talk about I when we are at a certain index, but for now, O of m, the whole list, and meaning the number, the count of the linked list. So this will return again a value, not a linked list node, the value, a discardable result. We might not care about that value. And public mutating func and remove last. Okay, and this will return a value. Here we go. So we need to, well, it's missing the method, it's something a return. But for now, what we want to make sure that there is at least one element that we can remove. And how do we do that? We want to make sure that we have at least the head. So guard let head, else we want to return nil. If there is no head, then there is nothing to remove. So we're just going to return nil for that value. Also, there is this edge case when we only have one element, which is the head. We want to basically pop. We already implemented that. So guard head dot next is not equals to nil. Sorry, not next, right over here, not equals to nil. Else, we want to return pop. So basically, we want to make sure that the next value is not nil. If it is, then there we have only one element, then we are going to pop. Now, if there are multiple elements, then first of all, we want to iterate through all of the elements. So how do we do that? We are going to go through the previous and the current heads in a while loop, and we're just going to iterate all the way up to the end till our next element is nil. So we have a previous that equals our head, and then we have our current. That's also our current, our head, not variant, but current. And then remember, we want to go through up all the way till our tail, which has the next value as nil. So while there is a next, while let next equals current dot next, we want to go up. So the previous will be our current, and then the current will be our next. Okay, so we just go all the way up, and then we unlink our tail. So previous dot next is something at this moment, so we want to set it to nil, so we unlink it. And also we want to update our tail, so tail equals our previous. And finally we want to return our value that will be on the current dot value. Right. So one thing before we conclude with the remove Rust, we also want to defer our count. So count minus equals 1. You know, we are removing a node. Okay, so that's how we remove the last. Now, what happens if we want to remove an element, you know, a node after a node? So let's do that first. And also, after that, we are going to remove at a certain index like we did with the insertion. So let's create our new function over here at discardable result. Let's have some more space. Again, a public mutating function, and it's going to be called remove after node. That will be a linked list node of type value. Oh, sorry, linked list node value. There we go. And it's going to return the value of the removed node. Now, why do we want to remove after the node? As I told you before, we need to go to that particular node, what we want to remove, and then on the previous, we want to unlink it and then link the next one as the next for the previous. So let's do that in code. First of all, we want to grab our target. So guard let target equals our node dot next. There we go. Otherwise, we are going to return nil. So if that's not available, we are going to return nil. Great. And then we are going to return our target's value. The same things as we did with the pop. We will have access to the value only if we unlink our target node inside the defer. So defer, and then we are going to say node.next equals our targets.next. So we are skipping our current value, current node, and then we are going to say count minus equals 1. One thing to note here, there's an edge case. If the target that we want to remove after is the tail, then we want to set the tail to the actual node. So if target is equals to, like it's exactly the same as the tail, so 3 equal signs over there, then we're going to set the tail, not target, but tail equals to our node. Okay, so that's how we remove after a node. But of course, this involves also grabbing this node. And as I told you previously, we are going to do that with the node add, but this is kind of cumbersome, having 2 functions, one after the other. Why not just go for and create a new function called remove at index? So let me just copy this out make this a little bit faster, remove at index of type int, and this will also return the value, which is optional, of course. So this index, it could be anything, so we need to guard against that. So first of all, we want to make sure that it is valid. So guard index is greater than or equal to 0, and also index is less than the count. Okay, else we are just going to return nil. Great. Also, if the index is 0, then we're just simply going to pop. There is only one element, so we're just going to simply pop. Guard, let's say index equals, or rather not equals, because this is a guard statement. If it's not equals, then we move forward with the code. Otherwise, else, this is just simply a pop case. So else, we're just going to return the pop. Now, if the index is equals to count minus 1, then we want to remove the last one. So guard index, we want to make sure that this is not equals count minus 1, else we are going to say return remove last. Okay. Now that all of these edge cases are taken care of, we want to grab the previous node. So guard, because it's optional, what we are going to be returning, let previous equals node at index minus 1, else we are going to return nil. Okay, now that we got the previous, we are just going to return remove after our previous. Basically, that's it. Simple as that. A few lines of code, but it is a little bit more straightforward. So let's check all of these out. So we have this linked list. Let's just build this. And we appended, and we inserted. That's fine. So now we're just going to say linked list.pop. Let's see. And we do need to print out before we see anything. So linked list, let's run that. We should remove, yeah, one has been removed right over here, as you can see. And then let's just say linked list dot maybe let's go with the remove at and then index 1. So 2 should be removed. Let's just print out our linked list. Let's run that. There we go. 2 has been removed. And then linked list dot remove last. And then let's just print out our linked list. Okay. That would be our final check. We should just see 5. There we go. Really, really nice. Okay. So that's how simple it is to add all of these functions to your linked list operators. So we can just use linked list in a very, very versatile way. Now, this is just the bare bones, by the way, of a linked list. Make sure to subscribe to the channel, hit that notification bell, because the next video, we are going to make a linked list even better. We are going to make it a collection. So stay tuned.